Thank you. Welcome to Planet Scale Dashboards. It's one of the aspects of the IDP world that we've been talking about for the past hour. What you might call, application monitoring or system health observability aspect. I fully realize I'm the last thing separating you from the lunch slot, so I'll try and be brief and keep it fast and entertaining. You know this situation. Your dev team brought up a new service. They've built this gigantic castle in the background here, and you so far have successfully ignored all their emails. You've not done any monitoring, any observability for them because you said, yeah, I can do it tomorrow. And you get to eat your ice cream in silence or in peace. And now, shock horror, you get paged and no ice cream for you. Wouldn't it be great if you could go to some sort of, you being either the DevOps practitioner, the ops team or SRE team, or the dev team, right? If you could go to a monitoring or observability system where you only need to select the system you want to observe, and then you get out of the box, you get many dashboards showing you different aspects of your thing. So, for example, if it's an HTTP server, you get an HTTP dashboard out of the box. You get an overview of what's going on at like a global level, and you can then filter and drill down into different aspects of your service, different regions, different angles that you want to investigate as you try and investigate that page that you got. My name is Robert, as we already established. I've been at Google SRE for over 10 years in what you would call the internal developer platform team for monitoring and observability. Hopefully I will succeed in walking you through what we've done to make what I've just shown to you a reality for the past couple of years. So we'll look at how to make dashboards that are reusable, and so that you don't have to build all of your own things all the time. We'll also briefly look at how to make this scale and work at scale. And we'll look at what can we do with such a system in addition to just dashboards, right? Small disclaimer, some of the problems here we've applied at our scale, right? And that scale might not apply to everything. I'm fully aware that if you run something in the basement on a machine, then maybe you don't need such a solution, right? If you're not a company of multiple tens to hundreds of thousands of employees, maybe you don't need such a setup that's as reusable. We believe it might still be useful, but I fully realize that this is a scaling problem first and foremost. It's a problem also not only if you're trying to cater to a large employee base, but also a large user base, right? If you're trying to cater to billions of users, obviously your systems that you're trying to monitor are going to be much, much bigger, much more diverse, load balance, scale, and so on and so forth, regionally distributed, and so on. Last but not least, and maybe the most important thing, and I saw on the unconference whiteboard, there's already a suggestion to talk about monorepos. One of the distinguishing factors for Google is that we have all our code in a monorepo, or much of our code, and that really helps facilitate reuse, right? So we can make some assumptions about most systems at Google that you cannot usually make in a multi-repo setup. And so that facilitates both reuse of the tech stack for us, but also reuse of the metrics and the dashboards that you would want to have in such a setting. Before I dive in, I'll lead with a bit of fine print that the lawyers made me say. All of the tech that I'm mentioning, I'm mentioning them so that they make sense to you. Don't take it as a particular endorsement of any one thing versus another. This is also not a sales pitch, so this is not something you can buy on GCP. This is just us sharing our approach that we found worked for us internally for Google. And last but not least, this is the big suspense, basically, that I'm putting you all under. This is part of a paper that's going to be published roughly mid this year, which will have more of the details that maybe you might be missing, or I might have missed putting into this presentation. And with that, let's dive in. How do you normally write dashboards? You go into a blank slate and you put a metric on there, right? And for the metric, you say, okay, this metric I really want to have scope to this job. Could be your front-end job, your back-end job, whatever. And you go and write this, and that's your HTTP dashboard, or it's your services, your systems overview dashboard. And now you go and copy that 1 time, 2 time, 15 different times, and you end up with a huge growth of dashboards, right? You will have the same query, the same expression for your backend, for your middleware, for all the different services that you run. That's okay-ish, except for two things, right? Your queries might not be super trivial. Like you might want to look not at the number of HTTP requests right now, but over a sliding window for the last 5 minutes or whatever, right? And then you do that maybe for the front end, but you forget updating the backend dashboard to do the same thing. So you'll have a lot of divergence, a lot of duplication where this will not work. For Google especially, it will not work because we run many hundreds of thousands of systems. And so having hundreds of thousands of dashboards for HTTP services doesn't really scale, right? We can't maintain these dashboards and then expect to propagate updates through them or anything. And that's just one set of metrics. That's just HTTP. If you now start thinking about, okay, I also want to have visibility into my network metrics, my CPU metrics, my JVM metrics, and so on and so forth, you will be completely lost, and this will just not scale. So what we do is not super exciting at this stage. We parameterize dashboards by what we call dimensions, what most other products that you can get and buy out there call variables or template variables, right? So you have a dashboard, and then at the top there's a nifty little selector where you can say, okay, right now I want this dashboard to apply to the front end, the back end, whatever. And you can fill it in, and then the placeholder in your query will be replaced by whatever you selected. Very simple. If you do this for many queries on a dashboard, you end up with a dashboard that, in this case, an HTTP dashboard that works for any service that you can imagine, right? That's great. We have an HTTP dashboard now. Cool. Also, not very new at this point, right? Like, we didn't invent variables. That was a thing in many of the products that do dashboarding out there today. But by consistently applying this pattern, you get a couple cool benefits. One is you can statically determine where to link to, for example, in an alert notification, right? You have an alert that tells you, oh, there's more HTTP errors right now than usual. Which dashboard do you link to for the DevOps team, for the SRE to look at? With this, you can just link to that one dashboard that you've built, right? And then put in the variable and be done with it. So that's nice. You can put those things into alert notifications, or your wiki, for example, or whatever you have. There's a couple other things you get with this in the URL schema. Basically, you can obviously apply or navigate. When you have this for multiple dashboards, you can navigate from one dashboard, let's say the HTTP dashboard, to the network dashboard for the same job very easily, right? Because they all use this sort of like parameterization, and you just change the dashboard name, and you have the same service you're observing, but different metrics. And also you can do this, you can scale this to any number of things. So you can, if you bring up a new front-end stack, if you a copy for staging, for example, right? You can use the very same dashboard that you've just built. Or if you're doing a rewrite of your front-end, same story, you don't have to start from scratch, you can just reuse what you had in terms of monitoring. Now, if we do this, there's going to be a different problem. We are building lots and lots of dashboards, right? We said the HTTP dashboard, the network dashboard, the CPU dashboard. There's just going to be a lot of them. You have a long, long list of things, and then even if your particular service, your particular system you're trying to observe isn't written in Java and Go at the same time, I think few things are. Or if your storage system, for example, isn't talking HTTP but some proprietary protocol, you will still have that nasty dashboard in there, and it's just going to be super confusing. So really what we want is some sort of filtering, especially in our case where we have built thousands of these kinds of dashboards for different sets of metrics. And so scrolling through a list of 1,000 dashboards, that's just not going to work, even for a search company. So what we actually want is for this list to be kind of filtered again, right? So if the system that we're observing, let's say the backend in this case, isn't written in Java or running on a JVM and isn't using threads, let's say, then we don't want to see those dashboards in the list. We want to see just the dashboards, the reusable dashboards that apply to it. And we also want to have this work for all the systems, right? So we want this to work for our front end, our star system, and so on and so forth. So let's decompose, as we heard in the keynote today, let's decompose into smaller problems. First problem, how do we select which system we're trying to observe? Second problem, how do we then filter out the list of dashboards that are relevant for this service? First problem, fairly simple, right? In that list of dimensions that we had, job, instance, and location, as you might have in a Kubernetes setup, one of those is more equal than the others. It's more important than the others. And we lift that up basically and say, okay, that's the scoping mechanism of our observability solution. And you first select that, otherwise the thing will not work, right? You first have to select that job, the system you're trying to observe. And then you get the list of dashboards based on this scoping, basically. For the second problem, let's briefly look at the production landscape that you might or might not have. In this example here, you have 3 different jobs. And now we need some sort of component that talks to all of these jobs, all of these systems to figure out, okay, what's their deal? Are they HTTP servers? Are they written in Java? What do they do? So we need something that talks to them. You might call this service discovery, right? Service discovery is not quite the same, but fairly similar, where you have a component that goes out into the fleet and tries to detect, okay, what's out there, what exists. And then this component needs to figure out, okay, this system is an HTTP server, this system is not, this system is running on a JVM, this system is not. Let's look into detail into how these things would work. We call them traits. You could think of them as properties of the systems in your production landscape. And how you determine whether a certain trait is true or not for a system you want to observe can be fairly simple, right? It could be just as simple as saying, okay, let's look at the very metric we just had in our dashboard. And if that system exports the metric, great. Let's toggle this trait to true and then show the dashboard. And if it's not, then don't. You could get more fancy, right? You could not look at the metrics. Maybe your job isn't instrumented. Maybe your job isn't responding right now to telemetry requests because something is broken. So what you could do is look at, for example, open ports instead, or look at build dependencies, and so on. You can get infinitely fancy. You just need to determine these Boolean traits in the end for your different systems. And then what you do is you show the dashboard, right? So for everything that has the serves HTTP trait, you show the HTTP dashboard in the end. Fairly simple as well. Now, what if you want to reason about different things, right? Like we talked about, okay, there's services, could be things running on Kubernetes, services running there in a pod, let's say. But you might have different things you want to reason about, right? You could have databases. And they are not quite the same, right? The set of dashboards and traits and the semantics of them are not going to be the same. So what we have done is we introduced a concept called scope types, where basically the first thing you do is you select the type of thing you want to reason about and that you want to observe right now. So in here, could be a server, could be a database, could be something else. And you select that, and then you can go into the particular system or database or whatever that you have. This is nice semantically, right? It makes it a bit more navigable, and you can reason about the system more easily. But it also avoids namespace conflicts, right? Like you might have a database called photos and a front end called photos. And then that would just clash if you had to select it in the same selector, basically. You can scale this as much as you want, right? You can scale it to hundreds and hundreds of different scope types to model all the different resources that you have in your system. Could be, machine learning models, could be servers, indeed, could be pipelines, could be mobile apps, whatever. At Google, we, or our clients of the IDP, of the platform, have modeled roughly 100 of these. And so we have very different requirements and very different dashboards and observability needs for these as well. We could go a step further, right? And we could say, okay, these types of scopes are modeled as a resource as well. So here's an example how this could look like, modeling a cloud spanner database instance, and then you can do fancy things like saying, oh, okay, all of the instances of this thing have to comply with a certain pattern, so that you can do better auto-completion in the UI, that you can do automated checking when you build a link, and so on and so forth. Now, you might argue, isn't this kind of infrastructure as code? Like you get much of this, or you could get much of this with infrastructure as code, right? You have a Terraform file, let's say, and your Terraform file says, bring up a set of Kubernetes pods, and for them, bring just up the same dashboards, right? You might have in your Terraform instance, you might even have information about, is this an HTTP server or not, because you need to open ports and set security policies, blah, blah, blah. You could just do all of these things in your infrastructure as code configuration, really. Except for two small problems. One is normally your infrastructure as code setup won't be as fine-grained as your dashboards might be, right? Like you might have a dashboard that looks at your thread pools at a full moon only, and only if you're written in Haskell, right? That could be a dashboard because maybe the metrics are very specific for this use case. Your IAC system is not going to have this information usually. And so with this discovery mechanism that we discussed and the traits, you could cover these kinds of very fine-grained properties easily. The other thing is you might just not be using IAC, right? We heard previously that it can be hard to move all the things on the same IAC platform. Maybe you have multiple, maybe you have some things that don't run on IAC. You have like a local setup which you do want to monitor, but you're not going to write an IAC config for this. Maybe there's something experimental. So IAC doesn't really cut it for this case. Well, okay, you could say, not IAC then, let's do dashboards as code, because that's the new hotness. And you could do something like this, where you say, okay, make me a HTTP dashboard for my frontend, make me a, what did I say, thread pool at full moon, if you're written in Haskell dashboard, you could do that here, right? That works, except again, two small problems. One is, this would all be intent-based, right? So somebody has to explicitly, intentionally say somewhere that they want this kind of dashboard, and you can't just discover, oh, this is an HTTP server, oh, this is a Java binary, and so on, which at our scale scales much better. The other thing is, if your IAC or DAC system is broken at any given point in time, it might take away your dashboards, right? With the model I've described previously, what you have is dashboards that just exist. You don't even have to have them in DAC. You could, but you don't have to. And the dashboard never needs to be touched by any fancy automation that nobody understands. You can just have the dashboard there. And then even if your infrastructure as code, if your Terraform setup, let's say, breaks, this will still all work. And that's kind of what you want from an observability system, because when stuff's on fire, you want to be able to monitor and observe it. Okay, so what did we achieve so far with the model I've described? We started with dashboards that you had to copy around and was just a mess. Then we made those reusable so that you would have the HTTP dashboard, the network dashboard, the disk dashboard, let's say. We then made those reusable and also filterable so that you don't have to, even when you reuse the same dashboards across all your systems, you don't have to navigate through thousands of lines of different dashboards. And then with the introduction of this scope type system, we also made it generic so that you could apply it to any sort of monitored resource that you have in your system. All right, take a breath. You're almost at lunch, I promise. I'll drink something to keep up the suspense. There's one more thing before I let you all eat something, sorry. One other quality that you kind of want from a monitoring system, which is orthogonal but related to what we just discussed, is if you go to a dashboard, you can start with a global view, right? You could see the HTTP requests across all regions for your system that you're observing. Cool. But what you kind of want is to be able to go down into the nitty-gritty of the system and look at a certain task, because maybe there's this one machine down in the basement that's malfunctioning, and really you just need to kick that machine a bit and then it's just going to be okay again. But you need to be able to drill down from your global metric into that to do that. You could just write different dashboards, or you could have the HTTP global dashboard and the HTTP by region dashboard and the HTTP by instance dashboard. kind of works, kind of sucks also, because then you have 3x, 5x, whatever, however many levels of drill down you want to have. You multiply the number of your dashboards. Let's take a small discourse before we go to the solution. One other thing that makes solving this hard-ish is that for a large-scale system, a system that ingests a lot, potentially billions of time series, what you want to do is kind of aggregations, right? Like you have your raw data, and you do want to pre-aggregate data to, let's say, the region level or to the global level to see, okay, what's the global thing. And in Prometheus, for example, you would do this by just having those recording rules to say, okay, please aggregate away all labels or this label or whatever, and then have these different layers. In our setup, we often use like a global view, a taskless or a podless view, basically, and a taskful view, which is the very base layer of information. What we can do to jump between those very easily is we can define a graph, right? We can say, okay, look at the HTTP requests metric, and then to this graph add what we call variants. So you would have multiple different variants of a graph, one for the global level, one for the taskless level, one for the taskful level. And they're all part of one graph. And based on those dimensions that we discussed earlier, you would then select the right metric. So you don't have to say you get paged in the morning, you don't have to say which metric you want to look at or which dashboard you want to look at. The system will automatically and transparently just decide, okay, you asked me to give you a per location view, so I'm just gonna pick the aggregation level that still has a location in it. That's cool, but a bit toily and error prone, right? Like you then need to specify different variants for the same graph for everything you could possibly want to drill down into. That's okay if you have like a linear set of things, right? You want to look at the global view, the by region view, or the task, the pod view. But it doesn't quite work if you have multiple dimensions of things, right? Maybe your metric has other columns or fields that you want to look into, like referrer, for example, for an HTTP metric. And if you have all of these variants, then you're going to just typo things, right? And so on. So it's not really great to do this. So what we've done is we kind of decoupled the metrics, or the rules, if you will, and the fields that they expose. We call this labels, and we basically tell the monitoring system, hey, there's this global request metric, and it has a job and a referrer field, let's say, right? And then, again, the monitoring system will transparently just pick that metric by default, right? Because that's the metric with the fewest possible dimensions. So it probably is the easiest to query because it doesn't need to load as much data. And then if you go into and you specify a location, for example, it would transparently know, oh, yeah, okay, I know the global metric or global rule doesn't have the location, so I need to go to a different level. And you can do not only filtering, but also group by, right? Like you could say, okay, please show me all the referrers, not just one. Maybe you don't know which referrer is malfunctioning or causing you trouble right now. And then you can group by that as well. And the system will basically transparently apply these sum queries here in this example. If we were to assemble all of that into a single definition, all the things we just talked about, you would have a dashboard. It has graphs. A graph has variants. Each variant has this sort of like query or expression and different labels that it provides. And then also, obviously, the traits that we discussed initially, right? So that you can say, okay, this dashboard, please only show it for things where I've determined it's an HTTP server. Cool. That's the dashboarding story. In the last 52 seconds, what else can we do with this? There's a number of things, actually, that you can do with this, and 46 seconds are probably not going to cut it. You can obviously, once you have these dimensions and labels, you can make them much more structured, right? You can express dependencies, for example. You can say, no, it doesn't really make sense to go down into a single instance of a job if you haven't defined a location. Like looking at instances across locations, across cloud regions, for example, doesn't make sense. You can have dependencies, for example. You can have labels that don't actually are exposed, that are not actually exposed by your metric, but are exposed by an auxiliary metric that you then just join against. Right? We already established we need to do some query mungeing anyways, so you can just join transparently against your metric. And that's just on the dashboard side. On the scope side, we described there's a couple cool things you can do, and I'm just going to show one of them. You can, once you have these things, right? We said, okay, we have server resources that we monitor or scopes that we monitor. We have databases. You can connect them, and you can say, oh, this server is talking to this database. And then your observability system can automatically say, okay, you got paged for the server, but maybe take a look at these other things, the peers of the server or the databases is querying, and so on and so forth, so that you can go and investigate when you get paged during an outage. Okay, in the remaining minus 36 seconds, takeaways. With such a system that we just went through, we can make it such that dashboards can be reused with what we call dimensions, what you might call variables or template variables. We made it so that you can navigate these still through discovering which dashboards are relevant and attaching them to different traits. We made it so that you can make the system generic and it can be reused for different types of resources that you're monitoring. And also we looked briefly at performance and how to make this scale and perform well, even if you have hundreds of thousands of pod nodes, for example. My name is Robert. It was a pleasure. I'll now let you go to lunch, or maybe one more question if we have the time.